hydraulic system will have a number of filters and strainers and things to keep the oil clean. And you need all of those because there are a lot of sources of contaminants. When the oil comes in, it gets pulled in through the components of the system. It can be accidentally built in when the parts are made, and it can be generated as the cylinders and motors are running and little metal particles get knocked loose. So we have to have a number of filters and strainers. And you can see here that we have a strainer which has bigger openings in the tank, and that strains out the big particles before they get into the pump. Then a finer thing called a filter is in the pressure line and filters out finer particles before they go to the system. And then in the return line, there's another filter that filters out whatever might have been picked up as the system was operating and returns it back to the tank. The symbol for filters and strainers is a diamond with a dashed line across the middle, and you can picture that that's like the filter fabric or the screen with holes in it that let the catch the particles. Here's a schematic of the same. Back here, here's a picture. Here's a schematic showing the locations of the various filters and strainers. So here is the symbol of the suction strainer with the screen down in the tank. Then the oil gets pumped through the pump. Now the oil line is pressurized, and so here's a high pressure filter that filters out particulates before they get to the valves and cylinders. Then here's the return line coming back. This is a low pressure line because it's just draining oil back to tank, so that's a filter also. Different kinds of filter media in each of these, different operating pressures, but notice they all use the same symbol, the diamond with a dashed line. Then stuff gets connected with hoses and tubes, and the hoses and tubes get connected with fittings. Now, in a really big system where maybe the tubes are bigger than 1 inch in diameter, which we don't really see around here, in those really big systems you might see steel pipe, kind of like we use in gas or water plumbing. But in most common systems we see either metal tube or hose. And in tube, some common sizes are 3/8 and 1/2 inch. The end of the tube gets flared with a flaring tool, and then a sleeve or a ferrule goes over the top of it, and you get kind of a jam nut going on here to tighten everything down. Threaded fittings come in several different thread forms, including SAE threads, 2 different flavors of SAE, and National Pipe Thread Tapered Fuel Thread. That's what that stands for. What does SAE stand for? Society of Automotive Engineers. Then hose is more flexible, this rubbery stuff, and you often find it in 1/2 inch or 5/8 sizes. And it has fittings that get swaged on, they're crimped on, and you get a special swaging tool that crimps that on for you. Finally, accumulators. Here's an example of an accumulator. An accumulator is like a shock absorber, and in this rock crusher, this is just the top half of a rock crusher, if some tramp iron comes through the crusher like a bulldozer tooth gets in there that shouldn't be in there, it can't be crushed like a rock can. So when the crusher comes down on that tooth, it generates real high pressure. And what do you do to keep your system from blowing up? You have this accumulator, which is a gas-charged bottle with a diaphragm in the bottom. There, it looks like that. So an accumulator is like a shock absorber, and it also helps the system just maintain a constant pressure. There are different styles of accumulators. Really old-timey ones didn't have gas charging. They just had a weight. You can also have, in fairly small ones, you can have a spring, but most of the ones we find nowadays are gas charged, like we saw in the backup in this slide here. Gas and a rubbery diaphragm. The general symbol for an accumulator in any event is this elongated rounded end thing.